Hello, my name is Shaghayegh Aslanzadeh. I'm the PhD candidate at University of Tennessee, Knoxville. Today I'm going to present my paper with the title of ISFET Digital Readout Circuit with an on-chip MIPS processor. In this paper, the design of an integrated CMOS ISFET pH sensor with an on-chip 8-bit MIPS processor is presented. An ISFET device is a MOSFET where the gate terminal is adjusted by ions present near the passivation layer on top of the top metal layer. The front-end ISFET pH sensor is based on the voltage clamping technique whose output is converted to bitstream data. The average of the bitstream is proportional to the carrier frequency over a given time period. An on-chip MIPS processor is used for processing the aforementioned bitstream data and further calibration. A ISFET pH sensor system was fabricated in a half-micrometer CMOS process. The layout of the front-end transducer, digitizer, and processor and the photomicrograph of the fabricated analog front-end are shown in this figure. The simulated transient response of the ISFET sensor is shown in this plot. When varying the pH from 1 to 14, the output varies between 0.75 to 1.05 volts. This figure shows the relationship between pH and frequency of the front-end design for 3 different chips. The output frequency ranges between 21.70 to 27.90 kHz. The experimental frequency is read from the oscilloscope. In order to test accuracy of the chip, electrochemical testing was performed on the front end with pH 7, which was purchased from Innovative Science Solution. From the oscilloscope, the frequency is 180 kHz. The simulated and experimental transient response of the counter and the SR latch are shown in this plot. For the measurement, a carefully sourced mirror was used to sweep the input voltage from 450 to 1158 mV, which corresponded to pH values 1 to 14. The processor will convert the voltage to a pH value based on an initial calibration experiment. When data enters the processor, it passes through multiple pipeline stages. Calibration is doable after compiling and uploading the instruction code onto the fabricated processor. MIPS consists of several inputs and outputs. The inputs are clock, reset, and mem data, and the outputs are mem-write, ADR, and the write data. The clock signal is used for avoiding hold time problems. Reset signals initializes the processor to 0 and the FSM to the start state. If the reset is logic 1, the MIPS processor is in idle mode. If the reset is low, then the data from pH sensor is pushed to the general purpose registers. When the pH sensor output is valid on the processor input, the arithmetic logic unit will perform the preloaded instruction. To conclude, the design, fabrication, and result of a digital ISFET pH sensor with an on-chip processor based on voltage clamping has been presented. The pH to frequency ISFET sensor with the digitized counter as a readout consumes 206 microwatt of power. The MIPS processor consumes 36 milliwatt of power. Thank you.